So now I've opened up my NetBeans IDE 8.2 RC, and you can open up whichever IDE you use, or you can even use an online Java compiler of your choice. I'm going to go in the Projects tab. Under the Packages folder, I will be creating a new Java class, and I'm going to label it as singly linked list demo. And I'm going to create the Java class under our Projects tab. And now it has created a singly linked list demo class. And I'm going to create a main method which will have all of our main method command keys in this method. So now I'm going to create a private class, and the access modifier for this class will be private because we are going to be using the concept of inner classes in this program. So I'm going to label it private class node. And if you recall from our visual representation, a node is that rectangular square box that we use to represent each item in the linked list. And outside in our outer class, we're going to be using two variables. We're going to have the size, which is storing the number of nodes in our linked list. And we're also going to be having a node head. The node head is an object of the node class, and we're labeling it head, which will point to our first node. We will be using two variables inside of our private class node, which will be int data, and again, creating an object of the class that I'm in, node, we're going to be using the next pointer. Next pointer is really crucial, as in our visual representation, we use the node pointer to dictate the address of the next node. So now, within this private class node, I will be creating a constructor of the class. So I'm going to initialize these variables that I just created. So you can just call it as node, or you can even add an access modifier as private node. And I'm going to be using a parameter as entity, which is going to represent the data value. So now we have private node entity. This is our constructor for the private class node. And now we're going to initialize the variables we just created. So data is equal to d. And next is equal to null. So now we have initialized these variables. We will be adding more code and content to our outer class. So now I'm going to create a constructor for the singly linked list demo class. So now it's going to be public. So this class is public, so the access modifier of the outer class will also be public. So it will be public singly linked list demo. So now I have head is equal to null and size is equal to 0. So we're going to declare and initialize these just like how we did in the node class. So after this constructor, we will be adding more content to the program. So now you can just visualize the visual representation that we created and just try to visualize what type of methods we will be needing in this class and what type of commands we will be needing to our linked list in order to actually work properly. You can just think for 30 seconds. If you guessed we're going to be needing an isEmpty and isFill method, that is correct. We will be needing those two methods to determine whether our linked list is full or empty. So I'm going to label it as public boolean isEmpty. So this method is going to determine to see if there's a value in the node or not. So now we're going to use the return keyword. Return size is equal to 0. This is just a shorthand cut of writing if statements. So we can just write, instead of writing if else, we can write return size is equal to 0. And now we will be needing another method. This method is going to check our size, which is going to return the node size of our particular node. So public size. Now you can just mention or declare these methods however you would like, but again, we're going to need a return type of this method. We're going to use integer in this case. And we're just going to return our node size, which we declared previously. So now we have the basic methods and the basic constructor created for us. Now this is where we're going to be adding the core code for our entire program. If you recall, we need to add a node to the linked list. So we're going to do the public void, and you can label the method however you like, but just for simplicity, I'm going to write add, and it's going to be int data. Again, we're adding a data to our linked list. So now we're going to create an object of type node. So node n is equal to new node. And again, calling that new node constructor. And I'm going to have the variable of n. So again, node n is equal to new node data. So I'm going to have the variable of n, which I created here, and it says new node. So this new node is actually calling the constructor of this node class. Now we will be adding an if statement and an else statement. So first we need to check, is the head equal to null? If the head is equal to null, we're going to assign the new node to the head. So you can simply do head is equal to n, or head is equal to whichever variable you created your node as. Next, we will be having an else statement, and this else statement will do the rest of our adding. So we're going to have node, we can label it as node current node, is equal to head. And now we're going to add a while loop. So while the node that we just created, while current node dot next is not equal to null. So this is saying, so not equal to null, this sign over here is not equal. So while current node dot next is not equal to null, this is basically saying head dot next. Since we just assigned the value of head, it's going to be head dot next. And now we will be continuing our while loop statement and kind of adding in the command for it. So now we're going to write current node, which is the node of what we just created, our current node that our pointer is on, and we're going to say current node is equal to current node dot next. And now we're going to go outside of our while loop and write current node dot next is equal to new node, or in this case we are writing it as n. This line is the key because this is our linking line. This is what's doing the entire linking for the adding method. And now after this, we can simply write size plus plus, which is going to increment the size of our linked list. Again, I want to emphasize that this is the linking line. This is the primary reason how or why our entire linked list is going to connect all together. This is the key to our program. So now we have finished the add method. Now we will be moving on to the next method of our code. Now, I just want you to think to yourself, what other commands or actions we can do to our linked list that will enable it to link all together. We're just going to think for a few more seconds. If you guess delete or remove that is correct, we will be creating a remove method in our singular linked list class. So now we have public void remove, and again, we're taking the value of int data. So this remove method is also very important. It serves a function of removing the data value, removing that value from the linked list. So now you want to see here that it says public void add. But now, if you think back, should this data type or this return value be voided? Actually, it should be Boolean, because we are checking to see a true or false value if the data value can be removed. So we're going to say if head is equal to null, if the head is null, we're going to return false. Else, we're going to be writing head.data is equal to data. So if this, we're going to create another if statement. We're going to say if the head is null, return false. If head.data is equal to the data over here, int data. If this is true, we will be writing head is equal to head.next. And we're going to decrement. And we're going to return true. Now you can kind of see the correlation between the if and the other if statement. This is the main part where we're saying if head.data is equal to the one that we want to remove the data. So now we're going to be writing the end of our method, which will be our current node is equal to current node.next. And we're going to return false. Oh, oops, I forgot to declare current node. So we're going to declare node current node is equal to head. And we're going to put this line that I have here into a while statement or while loop. So we're going to say while current node dot next is not equal to null. And we're going to write if current node dot next dot data is equal to the data, again referencing what we want to remove. If this is true, we're going to say current node is equal to current node. Current node is equal to current node dot next dot next. Current node dot next is equal to current node dot next dot next. Now again, I want to emphasize that the reason for this line is because the dot next and dot next is referencing to our next pointers. If you recall back to our visual representation and diagram of this program, we use next pointers to reference the next value. So now continuing this, we're going to decrement the size. And again, for the remove methods, we're checking different conditions to see if we want to remove the data value from the beginning of the linked list to the end of the linked list or to the middle of the linked list. So we're going to decrement the size and return true. And we're going to say current node is equal to current node.next. So we're going to decrement the value of size minus. Again, this is remove method. We want to decrement. And in our add method, if you recall, we're going to increment the size. I'm just going to return the false I have over here. So now I'm going to quickly refresh how we are creating the refresh memory on how we are creating the remove method. So we have if head is equal to null, we're going to return false. If head.data is equal to data, we're saying the head, we're going to point it to the next. Again, decrement the size and return true. And then we have node current node is equal to head, and we're going to have a while loop. While current node.next is not equal to null, we're checking to see if the current node's next pointer's data is equal to what we want to remove. If that is so, we're going to do the removing. Now we're going to move our pointer to the next. For the final part of our program before we actually execute it is our display program. So I'm going to write public void display. And we're going to say if head is equal to null, we're just going to print out the linked list is empty. And if it's not null, we're going to say node current node is equal to head. So our current node, let's put it back to the head. And while current node is not equal to null, we're going to print out the current node dot data. And then again, just to leave some spacing, I'm adding a plus and then an open and close quotes. Again, we're going to print out each data value that we put. And then inside of our while loop, current node is equal to current node dot next. So in this method, this is our display method, and are going to write current node is equal to current node dot next. This is saying going to traverse through the while loop, but going to say while current node is not equal to null, print out the first node, which is our data value, and then current node is equal to current node dot next, and then keep on going through to the end of our linked list, which is again referencing all of our code that we have so far. This is the most crucial step because this is where our linked list will actually get outputted in the compiler. So now I'm going to go into the main method and call all of these methods. So I'm going to call the singularly linked list demo class. I'm just going to call it my list is equal to new singularly linked list. Again, this is calling the constructor of our class. Singularly linked list demo, this is going to call our constructor. And then I'm just going to add, I'm going to write my list dot add, which is calling the add method. I'm going to add -1, 10, then I'll add another one of 25. And then I'm going to remove -1. And I'm going to remove 25. Again, calling the remove method. Okay, so now we've added it and we removed it. And now we need to utilize all of the methods we've created. So far, check on the add, check on the remove. Now I'm going to see if our stack or our linked list is empty. So I'm going to call the isEmpty method. I'm going to print out stack empty, and it will be a true or false because, again, our isEmpty method is a Boolean method. So you could say stack or linked list. So linked list empty, and then concatenate my list dot is empty, and it will print out a true or false value. And I'm also going to print out the size of our linked list. And again, concatenate it, list dot size, my list dot size, which is again saying the name of your list and then calling the size method. And then I'm going to call the my list dot display. This is the main part where it'll display everything. And I'm going to now, I will just execute the program and run it. So right click, run file. And it's just running it. So now linked list empty, false. Yes, that first line is correct. It is false because our linked list is not empty. Our size is 1. Yes, that is correct because we removed 2 elements and there were 3 to begin with, and 10. So yes, our program is working successfully. And now you can even take this program even further, and you can also accept users' input of which values they would like to enter using Java scanner class. Or in other words, if you would like to take the program even further, you can add in different ways of using the linked list class, which we'll be showing now. Now we'll be moving on to how you can take linked lists even further. Okay, so now that was a complete implementation of single linked list demo. Thank you everyone for watching. Happy coding, and please subscribe and give this video a thumbs up for more coding content. Have a great day.